I got this feeling inside my brains. It goes electric wavy when I make them A's. All through 4th grade, all through my school, we're flying up no ceiling when we're in our zone. I've got that sunshine in my pocket, looking forward to a good day. I feel I can do everything when I try. I can't stop myself from learning, moving up academically. We'll unlock the way we rock it, so don't stop.
Hello everybody, I hope you're having a great day today. Today we're going to be learning about why do I need to know about expressions and equations strip diagram. So that's going to be TEK 4.5a. So today we're going to be learning about strip diagrams, and if you don't know what strip diagrams are, it's basically turning the word problem into a picture, okay, using strips. So we're going to be doing a lot of drawing today, a lot of drawing strip diagrams, a lot of pictures to represent what the word problem means, okay? So when you have a word problem, we're going to turn it into a picture. That's basically what we're doing, okay? And don't forget to pause the video right here and write down what is on the screen, okay? So today's objectives are: students will know how to represent multi-step problems involving the 4 operations. Students will understand how to use strip diagrams to represent multi-step problems. Students will be able to share in a group discussion how to represent multi-step word problems involving the 4 operations, with whole numbers using strip diagrams and equations with a letter standing for the unknown quality. And here it is in Spanish, okay? Aquí está en español si lo necesitas. Essential questions. How can you use strip diagrams to represent multi-step problems, okay? And here's some important vocabulary, okay? Strip diagram, variable, and equation. A strip diagram is a model that can be used to help represent mathematical problems. For an example, here is a picture of what the problem is asking us, okay? So we have 2 bars, we have the question mark and a 2. And we know the total is 8. So if the whole thing is 8 and part of it's 2, what do you think this is going to be? 6, good job. So 6 plus 2 equals 8. That's what a strip diagram is. Variable, a letter or symbol that stands for a number or numbers. So here, my x is my variable. So x plus 5 equals 8. Something plus 5 equals 8. What is that? Good, 3. 3 plus 5 equals 8. So my x is 3. That's my variable. Here, my question mark is my variable because I don't know what it is, but I can still solve for it. Equation, a number sentence that has numbers, operation signs, and an equal sign. So an equation is just this. You've seen this since basically 1st grade, okay? So an equation is 2 plus 8 equals 10. So how do I know this is an equation? Because it has numbers, 2, 8, 10. It has an operation sign, plus. It could be minus, multiplication, division, but this one is a plus. And it has to have an equal sign, okay? So this is an equation now. Now you know what's the proper name for it. All right, let's go ahead and watch this video. I think it's going to be very interesting.
So our lesson today is going to be all about strip diagrams, how to draw and interpret them. So a strip diagram, also known as tape diagrams, bar diagrams, or bar models, are drawings that are used to illustrate number relationships. We're going to be referencing this anchor chart today to help us not only draw but also interpret strip diagrams. So the first question we're going to ask ourselves is, do we have a total? So in our word problem, we're looking for a total, or we already have a total. If we already have a total, this means that we need parts. So then we're going to ask ourselves, do we need equal parts or groups? If we answer no to that, we don't need equal parts or groups, we know we're going to be subtracting. If we answer yes to that, we do need equal parts or groups, we're going to divide. So going back to, do I have a total? If I answer no, I don't have a total, my total is missing, I'm looking for a total, it means that we have parts. So then we need to ask ourselves, do we have equal parts or groups? If we don't have equal parts or groups, we're going to be adding. If we do have equal parts or groups, we're going to be multiplying. So let's go ahead and look at some types of strip diagrams. Our first type is our total unknown. This means that we don't know our total. So the example we're given is Lucas has 12 glazed donuts, 4 chocolate donuts, and 8 sprinkle donuts. How many donuts does Lucas have? So in our strip diagram, these bars, this top bar and these bottom bars, are equal. Notice that they go the same length, meaning that they are equivalent or equal. So that means that this D up top, which represents donuts, the total number of donuts, has to be equal to all these bars on the bottom. So this 12, 8, and 4, when we combine them, it's going to be equivalent to D. So our equation, we could say, because our parts are unequal, we know we're going to be adding and not multiplying. Our equation would be 12 plus 8 plus 4 equals D, the total number of donuts. So you may also see strip diagrams represented with a line instead of a bar. It represents the same value. It's just saying that this line holds the same value or is equivalent to this bar. Our next type of strip diagram is difference unknown. So our example reads, Michelle wants roller skates for $78. She has $33 in savings. How much more money does she need? So we're going to let the variable R represent roller skates, which represents the difference or how much money Michelle still needs. So we do have a total in this question. Michelle needs a total of $78 in order to buy her roller skates, but she already has $33. So we need to figure out the difference between 33 and 78 to find out how much money she still needs. So our equation would be 78 minus 33 equals R for roller skates. So again, we may see our bar model represented with a line instead of a bar. It still represents that missing quantity. And our last type of strip diagram is parts unknown. So our example reads, Esther picked 3,510 apples on her farm. She gave away 1,275 apples, sold 1,180 apples, and kept the rest. How many apples did Esther get to keep? So we do have a total in this question, so that means we're going to be looking for a part. So because our parts are not equal, we know we're not going to be dividing, so that means we're going to be subtracting. So we're going to let the variable A represent the apples that Esther kept. So I know because I'm starting with a total, I need to take away these parts in order to find my missing parts. So I'm going to take my total, subtract 1,180, and also subtract 1,275 to get the apples that Esther gets to keep. And again, we see this line that represents the total, all of these boxes combined, and notice that it is the same size or equivalent to the bars beneath. So let's go through and let's do some word problems using this problem-solving strategy. So our steps for problem solving is going to be to read the problem. We're then going to write an answer sentence. We're going to find out what information we're given in our problem. What do we know? Then we're going to draw a strip diagram or a picture model representing the problem. We'll solve and check our answers.
All right. I hope everyone can see me. Okay, so that is it for today. I'm gonna stop the video right there. I'm gonna give you your notes right now. Okay. So here are your notes, and we're gonna be doing mini lessons throughout the week so that way we can get to practicing. Make sure you copy these notes in your notebook, okay? They're very important, okay? And make sure you just don't copy them. You actually read what they're saying because this is gonna help you for that part, okay? I hope you have a good day, and I'll see you in the next couple of days. All right, bye.